So we're going to talk about the equation of a line in standard form. So far, we've always used slope-intercept form of the line. And the slope-intercept form of the line looks like what we've talked about already, y equals mx plus b, where m is the slope and b is the y-intercept. Just like any other equations we've seen before, this can also be rearranged in any fashion that we want. So we're going to take the equation of a line y equals 2x minus 6, and we're going to isolate for 6, positive 6. So y equals 2x minus 6. Well, I have a positive 2x. I'm going to bring that over, so it'll be y minus 2x equals negative 6. Well, I don't want negative 6, I actually just want positive 6. So everything is going to be divided by a factor of negative 1, or multiplied by a factor of negative 1. However you want to do it, it's the same thing. So then I would have negative y plus 2x is equal to positive 6. If I isolate for the variable x, y equals 2x minus 6, I need to be bringing this negative 6 over, so it becomes y plus 6 is equal to 2x. Divide everything by a factor of 2, which would then give me y plus 6 over 2 is equal to x, or our isolated variable of x. When we talk about isolating for 0, we're also talking about set one side to 0. So what that looks like in this equation, y equals 2x minus 6, I'm looking for either the left side, or the right side to be equal to 0. Now, how do we get a side equal to 0? Well, I'm going to take the left side here and just set that to 0. How do I make the left side 0? Well, I just subtract a y from it. Now, what I do to one side, I have to do to the other, so I have to subtract a y from the right side as well. So if I rearrange this equation now, or rewrite it, 0 equals 2x minus 6 minus y. And we know this, or we're going to understand that this is what's called standard form. So when we're trying to graph lines, now we have y equals 2x minus 6 there for us. When I take my x value and I plug it into my equation, I get a y value. So y is equal to 2 multiplied by, well, in this case, negative 2 minus 6. It gives me a value of negative 10. Y is equal to 2 multiplied by negative 1 minus 6 gives me negative 8. Negative 6, I just kind of keep plugging in those values, negative 4 and negative 2. And you notice that we have our first differences are all the same, and they are all positive 2. So that chart is done, or table of values is done. The next line we have is in that standard form we were talking about. 4x minus 2y minus 12 is equal to 0. Well, if I try and take my x value and plug it in, I would get 4 times negative 2, which would be negative 8, but then I'll have minus 2y minus 12 equals 0. That doesn't really give me a nice output for my y value, so I need to rearrange and I need to change this into slope-intercept form. So at the bottom here, I just have written out that standard form equation of the line. I'm going to take this negative 2y and I'm going to bring it over because I'm trying to make it into y equals mx plus b. So I'm trying to make my y, isolate my variable y. So when I bring that over, I then have 4x minus 12 is equal to 2y. Now to isolate my y further, divide by 2, divide everything by a factor of 2, and I'm left with my y isolated. 4x divided by 2 gives me 2x. Negative 12 divided by 2 gives me negative 6. This is the exact same equation as what we've seen in that other table of values up top. So this equation here is the standard form of our equation over here. So what that means is that the x and y values are going to be the same. So this would be negative 10, negative 8, negative 6, negative 4, and negative 2. So if I'm going to go ahead and plot these lines, I simply ask myself, when x is negative 2, my y value is negative 10. Gives me a line right about there. Oh, pardon me, a point right about there. When x is 0, y is negative 6. When x is 0, y is negative 6. When x is 2, y is negative 2. So I have this line right about here. So the line that this represents would look something like that. So both of these lines, or both of these table of values, satisfy this line here. So which form is easier to graph from? Well, slope-intercept form would be easier to graph from simply because we can input the numbers into the equation and then we would get the other value. We input the x value into the equation and we would get the y value as the output. So when we talk about equations of a line or slope-intercept form, we know to be y equals mx plus b. Our standard form, equation of a standard form, is ax plus by plus c equals 0. So the term with the x, there's a term with a y value, and there is a constant term represented by the c. And you have some examples down here. 7x minus 8y plus 9 is equal to 0, and 4x plus 3y is equal to 0. There's no constant value on the last one here, so we just write it as 4x plus 3y is equal to 0. So there are some rules when it comes to standard form. All the coefficients, a, b, and c, are integers. They are not decimals. The coefficient of the x term, a, must be positive. If it's negative, we would simply multiply both sides by -1 to change the signs. So we're going to practice expressing each equation in the form y equals mx plus b and identify the slope and y-intercept. So I need to express the equation in the form y equals mx plus b, identify what the slope is and what the y-intercept is. And just as a quick refresh, slope is indicated by m, and our y-intercept is indicated by b. Do a better job with b. There. So I have x plus y minus 3 equals 0. Well, I already have a positive y, so I'm going to leave that there. I'm going to bring all the other terms over. So I would have y is equal to negative x. Y is equal to negative x plus 3. So then I need to identify my slope and my y-intercept. Well, my slope is -1, because we know that there's a 1 here, and my y-intercept is 3. X plus 2y minus 6 is equal to 0. Again, I have a positive y value or a positive y term already. I'm going to leave that alone. I'm going to keep 2y over here, bring the other terms over, negative x minus 6, divide everything by a factor of 2, which would give me the y, isolating the y. This becomes -1 over 2x minus 6. I need to identify my slope and my y-intercept. Well, my slope is -1 over 2, and my y-intercept is -6. Last one we have, 6x minus 3y minus 15. I have a negative y term, so I'm going to take that and bring it over. 6x minus 15 is equal to 3y. Divide everything by a factor of 3. Divide everything by a factor of 3 to isolate for my y value. I would end up getting 2x minus 5. What is my slope and what is my y-intercept? My slope in this case is 2, and my y-intercept is negative 5. So we've converted from standard to slope-intercept. Now we're going to go the other way around, converting slope-intercept to standard form. Again, standard form right here, ax plus by plus c is equal to 0. So I have my slope form for this line here. I need to set one side to 0. I'm going to set this side to 0. And how do I do that? Well, I would subtract a y from it. So it would be 0 is equal to negative 2x plus 1 minus y. Oh, hang on a second. I think I need to check my rules. And here it is. The coefficient of the x term must be positive. So, is the coefficient of my first term of the x term positive? No. So I need to multiply everything by negative 1, or I flip the signs of every term. 2x minus 1 plus y. Second equation, y equals 4x minus 3. Again, setting one side equal to 0. So I'm going to be setting my left side to 0. So my left side is 0. That means I brought my y over. 4x minus 3 minus y. Does everything satisfy? Yep, my positive is here. They are integers. They're not fractions. So that's pretty straightforward. All right, last one here. Okay, we got some fractions. Again, setting one side to 0. So I'm just going to go ahead, set that to 0. 2 over 3x minus 5 over 2 minus y, because I brought that y over. Now I have two fractions. So I have a denominator of 3 and a denominator of 2. So that means is I need to multiply I need to multiply every term by 3 and 2. I'm going to chop this up a little bit. So my first step, I'm going to multiply everything by 3. Minus 5 over 2 minus y, just spacing it a little bit more. So I'm going to multiply this times 3, multiply this times 3, and I multiply this times 3. Like technically I'm multiplying this times 3 as well, or by 0 times 3, but we know that's going to be 0. So what happens when I do that? I have 0 equals, well, these 3 cancel. 2x, 3 times negative 5, negative 15 over 2. Negative 1y times 3, negative 3y. Second step, I still have a denominator of 2. So I need to multiply everything by 2. 2, multiply by 2, and multiply by 2. 0 equals, well, 2 times 2 would be 4x. This then becomes, those cancel out, so minus 15. Negative 3 times 2 is negative 6y. If you want to be consistent with it, we can just simply rearrange this formula so that we satisfy our term up here, or this kind of formation of the standard form. 0 equals 4x minus 6y minus 15. Both ways of writing it are correct. I simply just chose to rearrange it so that it matched what the standard form is expressed as in the example above.